Mr. Yatin Pandya, who opines, forget the moon, let's reach for the sun. Mr. Yatin Pandya is an author, academician, researcher, as well as a practicing architect with his firm Footprints E.A.R.T.H, Environment, Architecture, Research, Technology, Housing. He has authored several books, especially on concepts of space in traditional Indian architecture. He has won numerous awards for his work, the most recent being the United States Curry Stone Foundation Design Prize for Sustainable Practice. So, let's welcome Mr. Yatin Pandya.
My title, as it says, Forget the Moon, Go to the Sun, was basically with reference to that we have long back conquered, or if at all not conquered, touched the moon, and we have laid our flag on the surface. I think we can be a little more ambitious and go further. Where right now sun comes to us, if we can go to sun is the point. When we say solar power, I want to break it down and widen that scope, because each of that has its own utility and its own contextual applicability. So rather than taking a vow that it has to be, when we say solar, it is only PV panel, I think solar power can be harnessed in more than many ways, through architectural design, subsequently through detailing, and then finally through accessories and so on. So it is in that context, I'm trying to widen that scope of discussion to say, and first thing first, design. But before that, when we say solar power, we have to say it in three separate kind of breaths, so to say. So first, sun and light, illumination, then sun and heat, and then sun and energy. And if we understand each in its own merit, we would have respective responses. And as I say, in the priority, first with design decisions, second then with the kind of detailing, etc. of it, and third with the accessories and the technology support that we get today with the present day know-how. So if we say sun and light, this is exactly where, see, if the basic statistics are to be kind of governed by, then in a residential area, which is less than the need of the offices and those areas, residential areas, you have 92% of energy spent in cooling and lighting. In an office spaces, it is opposite, that it is more during daytime, so more on the cooling, less on the lighting. And in the kind of residential area, it is more for the lighting, less for the cooling, if you don't have the excessive air conditioning and stuff like that. So now the point is, therefore, yeah, we are blessed with excessive sun, more than the sky component that we need. So if we are able to maximize that, our challenge is more to diffuse light rather than to gain the illumination, So through design, if we are able to create a footprint or a floor plate in a way that your natural light can access all the way in. Now, for example, right now, most of the commercial building that we do, we use edge to edge. That's not a problem. But earlier we had a wisdom of putting the courtyard or some sort of puncture, maybe atrium or so. Now, even if that is not acceptable, then at least the sawtooth thing, the edges. Okay? For example, there was a phase where, in order to maximize the periphery of the, building profile, we used to have more of zigzag periphery, the sawtooth thing done on the edges to maximize the perimeter. That was to flout the law of the extension of the balconies and so on and so forth. So we were extra creative to exploit those potentials by maximizing perimeter through those zigzag manner build form. Same thing if we do for gaining the access to the daylight, we would be able to not only plan each space with a view and the ventilation, but also maximum daylighting. And that way we would be able to reduce. So undue consumption of daylight during the daytime is something we can save. So sun and solar light. Now in the same, if we go by the technology, now we have these internally reflective surfaces which could illuminate internally without any power, without any other need, mechanized need, and it can even illuminate the basement with the natural daylight, etc. So that is one part of daylight and its maximization. Like what gave us a hotel or an institution, so that even in a daytime we have to use artificial energy. So at least we can keep provisions through our creative designs, which we always used to do. So I think we should think back on those parts where undue need of ventilating or lighting in daytime is avoided. So that's first part. Now, sun for heating. We have many applications. We used to have this solar cooker, whether it's a very naive domestic cooker or it was a properly managed institutional cooker, where heat for heating is one of the direct applications. And that is the most kind of energy efficient application. So whether it's a water heating area, or whether it is using the subsequent or substitute energy for air conditioning, etc., some of these applications can be considered, especially in industrial and commercial applications. Of course, domestic and the institutional, where there's a mass cooking, etc. happening. I'm not trying to bring it to very basic level, but what I'm trying to say is that by separating this, we will have design strategies and architecture responding to it accordingly. So for example, the typical kind of a recommendation of a kitchen to be in the southwest, so that most of our hemisphere experiences southeastern sunrise and southwestern sunset. So most of the morning time where you need that sun, even for vitamin D3 or even for grain kind of healthiness, etc., is available, even to dry out the dampness in the cooking area, keep it hygienic, etc. So I think once again, by zoning spaces in a way, you can optimize that. So that is heat for heating, and there are many applications, and so I'm not trying to waste time on that. Third, for energy. Now, of course, there we have two choices, battery or no battery, but luckily in most of the states now you have the subsidy, so that you don't have to change with wattages directly feeding to your gadgets, etc., from 230 to 110 and 110 to 230 again and stuff like that. You can directly send it to grid. So battery part has more or less been eliminated. You can produce energy and harvest energy and send it back. My point of discussion here is, and also to the manufacturer of the panels, that first of all, most common sensible thing to do is to, like in the region that I come from, 21 degree to the south is the kind of inclination that it needs. Can be not integrated in architecture. So rather than that as an afterthought, if you integrate it in the design, there are 2-3 kind of ways. That one is that your own roof can be at that level and in that profile, on which you just simply lay it, which will give you insulation, which will become a natural kind of a surface on that particular roof. And it would also be a way in which you would be able to kind of compose your building for its aesthetic reasons, etc., rather than something adjunct coming in later. Okay. Other is that if you use it, well, I'm only reflecting on many places, especially institutions, if I see that people put it on the terrace itself, and then you are not able to use the terrace, and you're still kind of wasting a very important space that you otherwise get. So if you lift it and put it after the headroom, in fact, there are less chances of any shadows of even cabin, etc., falling on it. So efficiency is higher, and you would be able to use the entire surface below. And with that roof coming over, it would also insulate the terraces, etc., below. And especially places like apartment or even Mumbai, where there's very little open space for even living areas, and these terraces can become now partly shaded. It was almost like in past we used to have baradaris or chhatris. So on the terrace you could have some shaded area, so you can spend late evenings there, etc. So this is how we integrate in the design for any of this. As I said, my point of view to put across even for manufacturing unit and even for the installers is that we fully understand that Southwest gets consistent kind of sun falling on it, but it is a photovoltaic. I'm trying to argue this way that when we have in London and such places which are often cloudy, sky component is not that high, sun intensity is not that strong. And if we follow very rigorously the solar azimuth and altitude and shadow throws for those conditions, and then we arrive at the efficiency, I think in India, even the north side would get enough of sunlight, even the any orientation that we think of. And I'm going even a further extent that my whole south facade, vertical, paneling. Now I'm sure there are applications where this has been done, but even with the reduced efficiency, which is still a good efficiency to get, if we can integrate it into such surfaces, into vertical surface, etc., that would be even more than required efficiency, given the sky component, given the long hours of the sunshine, etc., regardless of orientation. This is not to defy physics, but it is simply to say that the capabilities of its energy production, even in the given sky component, need not go theoretically to one specified orientation and inclination. I'm very positive that it could also be a little more versatile with relatively diffused efficiency, but still adequate for the kind of purpose. So we can think of, instead of vertical glazing, if we can think of some of such applications, etc., even in a non-roof surfaces. And second point with that is that, like we used to have, watches where everything was concealed, and somewhere around late 90s and 2000 came a fashion where you were in a Swiss watches able to see the machines. And I think in today's technology, for that aesthetic, it would be nice to see the kind of chips and the circuits going through these panels, and it can be a very beautiful aesthetic. And in fact, some of this transparency can be captured also with its shadow patterns, etc. So I think if we, and there are applications, Christopher Bannon's one of the project, that is how it was made. But of course, that was a little scale project, so they were able to probably do it in that way. But even after removing that bottom opaque layer, if we are able to put it, let's say in the courtyards, in order to cover the courtyard, you place it on top. So, and you lift it a little above, so you get natural ventilation, you get diffuse light, and you still can appreciate the sort of semi-industrial aesthetic emerging out of that, and so on and so forth. So this is the way, if we can think of these three dimensions accordingly, and each of that in the way of integrating in architectural 6 basic design decision. The 6 basic design decision any architect takes, good or ugly building, have to take on our siting and location, so which calls for orientational choice, which calls for zoning, then movement and organizational structure, so which is where the functional zoning vis-a-vis orientation, vis-a-vis outdoor shadows and no shadows, etc. Third one is choice of elements. So whether it's a roof architecture, whether it's a wall architecture, essentially, so what elements in what way do we compose and manipulate and combine? Then material and technique. And once again, this is where solar power can be actively harvested or denied if it was otherwise adversely affected. Then the finishes that go with it. And in that, again, the sort of most of these is put externally can become an aesthetic element. Otherwise, with the kind of choices of smooth or rough, dark or plain, and absorbing or not absorbing, we can kind of define those. So all of those 6 design decisions, if we keep in mind with sun as our point of reference, and as a human entity, as a living entity, we've always been governed by all sorts of forces and powers of that. But in architecture, if we put that in center, then heat would be negotiated accordingly based on the climate and the zone which you are in, the function that you want. The light would be mostly exploited through a number of means, and then the energy would be generated. So it can be a reproducible resource. So on one hand, we consume less undue energy for electrical appliances, and on the other hand, we can generate as much. So even parking garages, a lot of open spaces. Rajasthan farmers have started energy farming in their barren land. If agriculture is a little difficult in a rocky area, you can actually generate energy and feed it to the main grid. So this is basically the starter for discussion I wanted to put across. Like to hear others' view and happy to hear.